Hello, my name is Frank Röder and I'm going to introduce to you Curious Hierarchical Actor-critic Reinforcement Learning, currently a submitted preprint at the International Conference on Artificial Neural Networks 2020. Our work is based on the paper Learning Multi-Level Hierarchies with Hindsight by Levy et al. 2019, which introduces the framework Hierarchical Actor-critic. This framework enables learning of a hierarchical agent within a goal-based environment of continuous space. Let us take a look at the example figure with two levels on the left. Level 1 is getting as input the current state st and the extrinsic goal gt to generate a subgoal action a1t, which serves as goal for level 0. Level 0 now has a fixed amount of attempts to reach this subgoal with its so-called primitive actions at. Level 0 returns if all attempts have been used up or the subgoal was achieved. This continues until level 1 runs out of attempts and a new episode starts. Here you can see a hierarchical agent generating purple subgoals to reach the yellow goal. As the reward is still sparse in such a goal-based setting, we came up with the following research question and idea. How can we alleviate reward sparsity and improve the learning performance with a hierarchical architecture? We address this research question by extending the hierarchical actor-critic with a surprise-based reward called curiosity. Curiosity had been used in many publications, but not in a hierarchical setting like the present. Curiosity itself is defined as the driving force to acquire new knowledge. To find what's new, a reinforcement learning agent tries to predict the consequences of its own actions and is surprised when its knowledge of the world deviates from its actual dynamics. With this, we can generate the intrinsic reward to alleviate reward sparsity and improve exploration for every level of the hierarchy. Despite significant evidence from cognitive science that curiosity is a hierarchical phenomenon, there exists no computational model to verify this hypothesis. We present the curious hierarchical actor-critic as an extension of the hierarchical actor-critic, in which we add a forward model to each level of the hierarchy. Our forward model learns the state transition function to predict the consequence of an action. The objective is to minimize the mean squared error between our predicted state and the real next state. We train our forward model next to our actor-critic by using the same samples from our off-policy memory. The difference, also known as surprise, is used as curiosity reward to temporarily update the sampled rewards. The new rewards are created by taking a fraction of the extrinsic reward, Re, in combination with the curiosity reward, Rc. Our hyperparameter eta defines this ratio. For this presentation, we take a closer look at two environments to demonstrate the training performance and the mechanism of surprise. On the left, you can see the ARNT reacher and to its right the ARNT for rooms environment. In both environments, we solve a shortest path problem. The agent should generate subgoals, purple, to reach the extrinsic goal, yellow. What we found out through our experiments is that curiosity improves and stabilizes the learning. Our plots show different values for eta next to the baseline. In the following a demonstration of surprise. Here you can see an ARNT agent trained inside the reacher environment, but deployed into the for rooms environment. The plot on the right shows the real-time generated surprise as two lines. The orange line belongs to level 1 of the hierarchy, and the blue line to level 0. Level 1 creates subgoals inside and behind walls because there are no such obstacles inside the environment it was trained. As the agent is not able to reach these subgoals, level 1's forwards model creates a large surprise. Also, level 0 is surprised by walking against the wall. You can see a peak of surprise and a sudden drop after the agent falls on its back. In conclusion, we extended the hierarchical actor-critic with a mechanism of curiosity to alleviate reward sparsity by introducing an intrinsic reward. This improves exploration and accelerates the training. Both surprise and curiosity are principles from cognitive science. Thank you for your attention.